So I had a LED light fail the other day, and I thought I'd share the fault troubleshooting with you guys. So typically when an LED light fails, it's the power supply that gives in, and you can test the power supply by either swapping the LED strip or maybe more advanced with some external resistance and see that you get the current that is expected at the voltage drop that's displayed. So in this setup, I had a 250 milliamp constant current type power supply that can deliver 250 milliamp at the voltage between 30 and 48 volts. But when I checked the power supply, I saw that was good. So I did an ABA test where I swapped out the LED since I had an identical light that I could kind of swap the LED strip, LED plate. And what I found out was that the power supply was good. So I started troubleshooting the LED plate, and I could see, just using a simple multimeter running for continuity, I could run a small current through each LED, and I could just see in very, very small light in the LED, which kind of indicates that the LED is operational. So what I did is I swapped the two LEDs that I removed the two LEDs that I found faulty. And because it's a constant current device and the same current goes through all the LEDs, I just replaced these two LED positions with a solder bridge to kind of bridge over that. And it seemed to work quite good for 15 to 20 seconds, but then I lost half of the LED lamp, and something was wrong, so I turned it off and went into a little bit more detailed troubleshooting. So what I thought was a little bit strange when the light failed the second time was that half the LED plate kind of went dark, and so I kind of opened it up and looked a little bit more on the construction. I could see that what they did is that they used one power supply to run a 250 milliamp total current, but the LED plate is kind of divided. So you run these 250 milliamps through two legs with the current sharing of 120 milliamp in each leg. So basically it's two parallel LED strips that they put on this plate, and it consists of 26 LEDs, but it's 13 SMD LEDs on each leg. And if we calculate 3 volt per LED, then we see that we should have a total voltage drop of 39 volts for the total device. So the problem here is that with this kind of parallel setup is that you need to consider the current balancing. So the current balancing here depends on the voltage drop over the two legs, and the voltage drop for each leg depends on the voltage drop for each individual LED. So with temperature, the forward voltage drop of the LED decreases, and that can cause an imbalance in the current sharing between the legs due to the different characteristics of each LED device. But on the other hand, looking at the forward current versus forward voltage, increased current increases the forward voltage drop, which kind of maybe rebalances the current sharing. But the problem in this kind of setup is maybe even if the current sharing works, it only works as long as all LED devices on this plate are fully operational. And typically not all devices are perfect, so they have a little bit of different characteristics. And here, when one LED device gives up, then it will cause an imbalance in this current sharing, which will cause more failures because the imbalance load will be carried by the other devices. And if you have a complete damage of a LED device, then the full current 250 milliamp will run through one of the legs, so severely damaging the other LED devices, which could give you even more damage. So what I realized I had to do was to check each LED and see if, even if the LED lights up, is it a good device? Does it work according to the datasheet? So I don't have the datasheet, but since I have 26 LEDs, if most of them kind of operate in the same way, I can assume that they operate correctly, and any LED that kind of sticks out probably has something wrong with it and should be replaced. So what I did is I used a constant current power supply, or a current limited power supply here, and I set the voltage to 125 milliamp, or 130 in this case, as a limit, and then I let the voltage float, and then I connected each of the LEDs to the power supply running 125 milliamp through each device, and then I could see, okay, do I get the rated voltage? And going through all the LEDs, I could see that I had most of the LEDs here gave a voltage drop of about 3 volts at about 125 milliamp, but some of the LEDs did not. So I could see that on one side I had 3 LEDs that were damaged. One of them that I earlier, the open LEDs I already removed, but then I had 2 additional LEDs on that leg that had voltage drops of 4 or 5 volts even. So what I did is, for one of these LEDs, I just made a jumper over it to close the circuit. But since I need a balance in the current sharing, I had to move one of the LEDs, one of the good LEDs, from from one side to the other leg to make sure that I have the same amount of LEDs on each leg. So now I end up with 11 instead of 13 on each side. But looking at the numbers, with 11 LEDs on each side, we get 11 times 3 volts, which is the nominal for these LEDs. I still end up at 33 volt, which is within the spec of what the power supply can deliver. So the power supply should be able to deliver the 250 milliamp total at 30 volts. So this way I kind of set it up. So I get a little bit less light, yes, but it comes out working, which is kind of what I could achieve. Another way would be to replace the LEDs completely, but then I need to find the make and model of each LED or of these LEDs, and then replace all of them. So here I just needed to move one of the LEDs, which was quite easy, using a powerful soldering iron to heat up the heatsink on the back and then just lift it off. All right, guys, thanks. Good luck.